The final insert contains an exterior view of the ballistic turret in the upper right-hand corner with the crew compartment view of the ammo doors on the full screen. Note the smoke around the ray door. The initial explosion consisted of propellant rounds detonated by a shaped charge. The low-order events seen are believed to be propellant rounds cooking off. It should be noted that at elapsed times of 31 minutes and 34 minutes, high-order events occur, which are heat-round warheads exploding. At an elapsed time of 23 minutes, cook-offs are still occurring, yet no smoke is visible on the screen.
The initial production verification tests of the hull and turret ammunition compartments were conducted on ballistic hull and turret number 8. Both hull and turret ammo door systems tested were assembled using production line components, personnel, and methods. The turret ballistic test was conducted on September 22, 1986. The charge went off as planned and produced a very violent event. The ammo door system performed extremely well and met all requirements. Although some smoke was observed to enter the crew area, the resultant toxic fume levels were judged to be survivable. This is proof that the design and production of the turret ammo door system is successful in preserving crew survivability during an attack on the ammunition. Several inspections of the door system were performed before and after shipment and after final closure to ensure it met all current TDP requirements. Before loading the ammunition, the ready door was operated through 200 cycles and the stowage door through 10 cycles to simulate normal break-in usage. The bustle was loaded with a full complement of ammunition, which is 24 kinetic energy and 10 heat rounds. The blast was initiated by detonating a shaped charge warhead that was mounted against the exterior wall of the bustle. All 10 heat warheads remained intact throughout the event. Although the relevant pressure reading was not recorded, extrapolation of other data indicates that the peak initial blast pressure was in the range of 2,400 to 3,000 psi. This is corroborated by the extensive structural damage seen in this test compared to earlier tests. Despite this, the ammo door system met all its requirements. The initial blast ruptured the bustle floor along 3 of the 4 walls in the ready compartment. The high pressure also bent the rear edge of the turret racing support casting downward. This structural deformation distorted the flat plane that both doors seal against. This is the cause of the small amount of orange smoke which leaked into the crew area at the lower right-hand corner of the ready and stowage doors.
One, zero.
The blast was initiated by a shaped charge warhead mounted against the left skirt. The jet passed through 2 rounds, which caused a violent initial explosion. The resulting fire quickly ignited the remaining rounds, causing an intense but brief burn-off of the propellant. The peak initial blast pressure in the ammo compartment was recorded at 264 psi. There were no visible leaks around the ammo doors. although low levels of toxic fumes were recorded in the crew area. These levels, however, were well below the specified limits. This test is proof that the design and production of the hull ammo door system is successful in preserving crew survivability during an attack on the ammunition.